Hi everyone, this is Alisa from Darwinex Labs, and thank you for joining us again. It's good to remember that if you've come this far in this tutorial series, we've covered a lot of content. There has been a lot to consume as regards the Darwin API, it being new and obviously being for an alternative asset class. So if you are here and you've gone through all the tutorials so far, we've covered the Info API, we've covered the quotes and WebSockets APIs. So we're in a position to do more actionable things with it, and coding all the time, getting different parts of APIs together, implementation-wise, can get a bit boring. We've done all of that, and all the example code that we've developed as we've gone through these tutorials has been shared for you on GitHub. We've done a quant workflow tutorial where we went through in essence, a basic process on how an algorithmic trader thinks, a quant trader thinks, about a strategy, how to go about generating ideas, how to go about testing those ideas and creating hypotheses and disputing hypotheses at the same time. We went through an exercise in Python. We shared a Jupyter notebook for the same, wherein we analyzed a portfolio of Darwins for a particular momentum factor. So that sort of use case has been covered. But now, as algo traders, we'd like to go ahead and start doing a few more things. So there are use cases that come up in terms of strategy development, something that we covered in quant workflow, but also to do with engineering a solution whereby you can actively perhaps monitor, similar to a trading platform. So if, for instance, MetaTrader users, you're quite familiar with and used to using the MetaTrader platform to analyze different traditional assets, such as the euro, dollar, any other currency pair, or stock or crypto currency asset, etc. In the Darwin asset classes case, we have the investor platform whereby you can go and visualize Darwins on the platform. With the Darwin API, you can exercise your own ideas, implement your own ideas with the API and create your own trading environments. And these could be backtesting environments, monitoring, visualization environments, such as a trading platform like MetaTrader, trading environments, of course, with the investor account info and Darwin Trading APIs, in conjunction, of course, with the Darwin Info API. And essentially, you have the flexibility, especially if you have programming experience or have an enthusiasm for getting your programming experience up to a level where you can engineer these solutions. The Darwin API opens up a whole world of possibilities for you in terms of doing that. So as of today, our tutorial series is going to take a slight turn for the better, whereby we're going to start building a Darwin trading terminal piece by piece, engineering the charting capabilities necessary to import Darwin data directly through the API. We're going to go through some software engineering principles as to how to structure the code, how to think about the project itself. We will also think along the lines of efficiency in terms of how to go about not bombarding the APIs with repeated calls over and over again for data that you could have stored or cached, and hence accessed quicker for yourself. So things like that, software engineering and trading strategy developer related concepts will be covered in detail. But as of today, we'll start building this terminal. And today's video is going to focus on the charting component. We'll build a basic building block that will be used throughout the rest of our series as of this point towards building this Darwin Trading Terminal. And of course, this is going to be an exemplary effort. So we're going to show you how to do it and create what is, in essence, a terminal. And we'll share all this code with you. It'll be built in Python using Plotly Dash, and all of it will be open source. So you can take that code base and expand on it, implement your own ideas, or submit pull requests with good ideas that you already have that you'd like implemented in our projects as well. And without further ado, let's dive straight in. I'll see you on the screen.
Right, so I've switched over to my Spider IDE, and we're looking at some code that's been written for you to get started on this process, this journey towards building a trading terminal that can achieve backtesting, live trading, and monitoring capabilities. We'll start with the very basic building block, which is the chart itself. By chart, I mean a chart that can both visualize Darwin data that you collect via the Info API, but also allow you to do some more traditional analysis activities on it. For instance, in today's tutorial, we'll be covering how to implement multiple technical analysis indicators using the popular TALib library and framework. Before we go into anything, in order for us to build this terminal in Python, we have several options, but we will opt for dash in this case, dash plotly, and that will allow us to essentially flexibly create this application as we add more components to it. In terms of structuring the application, the terminal to include backtesting, live trading, and monitoring functionality, we'll cover this in future tutorials where we'll dedicate a segment to just structuring the application, all the things that we'd like to be in it, and then iteratively expand on the project. To do so, we need dash, and we need four modules in particular. We need dash core components, dash HTML components, and dash dependencies. And these are all accessible via GitHub. Instructions for installing these are fairly self-explanatory, but we'll include a little README on our GitHub repository to enable you to do this easily. Then we need QuantMod. Now, if there are any R users watching this, QuantMod is a very popular financial charting library and was ported to Python by a gentleman by the name of Jack Luo over at Plotly, who has created a PyQuantMod project and released it open source on GitHub. You can download QuantMod from GitHub. Installation instructions will be provided to you on our README. And there are certain things that need to be adjusted when installing QuantMod, so I wouldn't recommend installing it via pip. It's recommended to install it from source using a slight modification to the existing setup file. We'll submit a pull request at some point to have that modification possibly implemented at source. But for now, it's a very simple modification to the setup procedure that enables you to install it without any problems. Essentially, that is the core base of dependencies that we need at this point in time to enable us to go ahead and start building this web-driven application. To start things off, since we're focusing on the chart today, we of course need a data source and we need to perform some calculations on the chart. These calculations including basic returns and cumulative returns for now, since we like to plot the chart and add a few studies to it in the form of indicators, but have the ability to add as many studies as we need. To enable all of those things, we'll also need one additional component called TALib. Now, QuantMod by default uses TALib internally. It references TALib, therefore we need to have TALib installed on the system and the associated modules installed in Python. Instructions for these will also be provided to you on our GitHub repository. So starting off with the class, we've started writing a class here that will eventually expand into multiple scripts with multiple classes, possibly loads of inheritance going on as we've done previously with the API-specific scripts, as you've noticed in previous tutorials. And to start things off here, we're going to specify a few things. Firstly, it's good to maintain the universe of Darwin assets locally in a cache and periodically update that cache so that every time you instantiate your application, you don't have to go ahead and query the API for the same list of Darwins over and over again. That list of Darwins will change. Of course, you have Darwins being added on a daily basis to the universe, but a more efficient way to deal with that is to periodically query the API based on the very last offset that you had, something we went through in a previous tutorial on constructing a Darwin universe. And then if there are any new Darwins that have been added to the universe, we download those and update our local cache. For this example, we've created a local pickle file, and this pickle file essentially contains the downloaded Darwin data, the universe, from the API via /products. Then we've also got a helper file here, which is again a pickle archive. And inside this pickle archive, you have a dictionary object that contains the name of the indicator that we'll be adding to the chart, along with a brief description of the indicator should you need it. This isn't a critical component at all, and it can be done without, but for sake of cosmetics, really, to sort of not only show the indicator, but also show some descriptive text about the indicator on our chart that we're about to build here, it's good to have that information handy at the present time. The very first thing we do is we create ourselves an Info API object, and then we read in the files, the Darwin universe as well. If the Darwin universe local cache is not found, which will, if you run this example as is, it'll be the first, if you run it for the first time, there will be no file. Therefore, you'll make a call to the Info API, get that Darwin universe, store it in a data frame, and then store that data frame to the PickleDB. That will create your cache. So the next time you load the application, it will load it from the cache instead of querying the API again for that information. Next, for this particular implementation, we need to create controls and the chart itself. Let me show you what the chart actually looks like prior to us going ahead into this code, so we gain an understanding of what it is we're trying to achieve. At a very basic level, this is what we're going to implement today. We're going to implement two dropdowns. Very, very simple. One of the dropdowns will contain the loaded list of Darwins from our cache, which was either loaded via the API or was loaded from a file. On the right-hand side, we're going to load TALib indicators, and these can be added to the chart that we're plotting at the present time. There is also the ability to plot more than one Darwin. So we'd like to be able to plot portfolios. That's the idea behind doing that. So the dropdowns have two types in this implementation. The right-hand dropdown is a selection-only dropdown, so you can only select a particular indicator. So for instance, Bollinger Bands. In this case, we have our Bollinger Bands updated on the chart. And we'll go through the construction of this chart here shortly, so you're completely aware of how to go about doing that. So the right-hand dropdown is a multi-dropdown. You can add more than one indicator to it. So let's add, let's say the RSI, and let's add a momentum indicator. So there we have 3 indicators. You can add as many as the chart will support. On the left-hand side, we have a multi drop-down as well, because our intention with future tutorials is to be able to plot a portfolio. So right now, the active Darwin, PLF, followed by, let's add another Darwin, let's say KVL, and let's add another one, NTI. And you can see that the portfolio is being constructed in real time. But remember, this is a very basic implementation. This portfolio right now in its current state is completely unreliable because it is not taking into consideration validation dates. It is also not taking into consideration any transaction costs, performance fees, effects of divergence, and other cases that we'll be covering as we progress in this series of how to build a trading terminal for yourself using Plotly Dash. So this portfolio is not to be relied upon at all. If you are interested in visualizing this portfolio, please head over to darwinex.com, sign into your account, and use the backtest tool, whereby you can have all those important concepts incorporated into your backtest, such as validation dates, performance fees, effects of divergence, etc., and then see a much more realistic visual of the portfolio constructed using these Darwins or any list of Darwins that you enter here. So in essence, the idea here right now was to show you what it is that we're going to be implementing and how we're going to write the code for them in Python, which is extremely simple. The example code has already been written for you and will be shared on GitHub after this tutorial is over. So let's go back to our code. So you saw on the chart that we need 2 dropdowns, and these are our controls. So the first dropdown we need is the tickers dropdown. We're going to load our list of Darwins from the load our list of indicators to be used later in the indicators dropdown. First Darwin's dropdown takes a label and a value, and it takes all active and deleted Darwins from the Darwin database that we loaded from the cache or via the get Darwin universe call to the API. And the second dropdown contains technical analysis indicators, these being imported from QuantMont. And QuantMont is internally referencing TALib, which is internally referencing the installed TALib framework on your machine. And that creates the dropdown over here. In terms of launching the Dash application, we need to create, every application needs to be specified as an application, and then it needs a layout. What is it that you'd like your application to look like? That is what a Dash layout essentially references. And without having strict form knowledge of HTML, it is fairly convenient to create HTML components such as this in Python using Dash. So here we're going to specify our layout, and then we're going to create some div objects and populate them with information that we'd like to see on our chart. I won't go into too much detail on each of these. You feel free to go through this code on your own, and it's fairly self-explanatory as to what component goes where. But essentially, we need a main div object that holds everything. We need a heading here because we'd like to say something over here prior to creating our first dropdown, second dropdown. A parameter an indicator parameters box where we can specify additional parameters for indicators, such as if you're familiar with a stochastics indicator, it will take some parameters, or any other indicator will take additional parameters as well. So this little basic implementation here allows us to do that. Going back to the code, we have our first dropdown, second dropdown constructed, our indicator parameters box constructed. We've also given them meaningful names that we'll be using to access later. And then some styling information here to basically do things such as background color setting, where you'd like the elements positioned, etc. Now in Dash, there are two important concepts to note. While I recommend that you go through Dash documentation in your own time, essentially, creating functionality in a Dash app requires the use of a decorator pointing to a particular set of controls and inputs, and a wrapper function that decorator wraps over. So for instance, we have our first decorator over here, an app.callback, and it references the parameter controls, and this is our indicator parameters box. And the wrap function is essentially display control to set its display property in HTML, CSS to none or inline block, as in display it if it's clicked, do not display it if it isn't. The next decorator we have is for the chart itself, and the chart relies on the inputs from the Darwins you select, the indicators you'd like to add onto it, and any additional parameters that you specify. And this decorator wraps the function update chart. And that update chart function takes the 3 inputs that we specified in the callback decorator as its arguments. We simply go ahead and create our dataset. This get Darwin Data Set function is defined over here for you, that accepts a list of assets, asks you whether you'd like cumulative returns, or and also if you'd like to rebase. And the definition of rebase in this function is, given a list of Darwins and their corresponding quote data, would you like to have a series of data plotted on your chart where all Darwins start from the same time period? As in, there may be Darwins in your list that are older than each other or newer than each other. Therefore, this rebasing functionality drops any data where there are nans found in the data. So that allows us to go ahead and create a series where everybody starts at the same point in time. This does a loose nan drop because the other not a number verification is done internally inside the Darwin Info API implementation in DWX_info API. So that was an explanation of how to get the data set. Once you supply the Darwins to the get Darwin dataset function, it will return to you a quantmod figure. And that figure is what we will be plotting on our chart over here. This figure will be generated by quantmod using data in the form of Darwin quote series and indicator trace series that you'll supply it. The code for this is provided over here. If there are any parameters that you specify, then they're added onto the chart. Otherwise, for each function, for each indicator that you selected in your right dropdown, that indicator's corresponding function inside the quantmod library module is executed on the chart figure that we've created over here via the get Darwin dataset function. Once everything is done, we convert it to a figure of type line because we'd like to plot a line chart. We give it a width of 1024 and we set it to, this is either light or dark. These are the two themes available to you in PyQuantmod. We adjust the fill color to a certain color to make it a little different from the default and return the figure, and that's it. This figure is then returned back to the element that it corresponds to. So in essence, that is the main structure of the application. For any element that you'd like to add to it, for instance, as in future tutorials, we'll be adding tables, we'll be adding order history centers, we'll be adding menu bars, radio buttons, and checkboxes to achieve different functionality. We'll be adding all sorts of things. We'll even be adding state indicators, state elements, to allow us to use the WebSocket or Quote API to stream real-time data into this application so we can create a monitoring interface. As you can see, it will get heavy and extended over time. But if you understand the main functionality of Dash, how to write code in Dash, it becomes extremely easy to go ahead and start thinking about functionality as opposed to just writing the code for it. Just remember that you need a decorator to wrap every function, and that decorator needs an output and input set of controls in it. The output and input controls must exist in your layout, otherwise they won't be of any use to the callback, and especially not the function that the callback is wrapping. And that's pretty much it. This code achieves this chart. So let's quickly run it. It's already running at the moment, but let's drop that connection and run it again, because there's one more element that I'd like to explain to you here. At the back end, the application is using Flask and rendering it as a web application on your local machine. Depending on the port you've selected, for example, the default port I've selected is 4003, it will then render that application on your local host at that port. To access that, we very simply go to your localhost and enter 127001, followed by the port that you referenced in your application before launching it, and it will load that application as a web application on your machine directly. If you have a Flask enabled hosting account with your web host, you can also publish this over there and share it publicly with your colleagues or other traders or any participants who'd like to involve themselves in developing solutions using the Darwin API. Right, so that in essence covers this tutorial on building a chart. All the other things such as the titles and drop downs and such were introduced into this particular tutorial to give you an idea of how to go about using decorators and wrapper functions when writing code using Dash. In future tutorials, we will expand this implementation a lot. We're going to add controls for practically everything that you would like to see in a standard trading platform. Let's assume MetaTrader, for instance, has several things, of course, that we won't need here since we're using Darwin assets. But generally, you have a list of assets that you can select from somewhere to the left or to the right. Usually, you have a list of indicators you can drag and drop onto the chart. We'll restrict ourselves to adding them via typing them in through a dynamic list like this. You'd also like to be able to conduct back tests, have an order history center somewhere. Things like that you normally see in a trading platform are all completely possible to build using Plotly Dash and the Darwin API. So we will go ahead and do this in future tutorials. Now let's go over and do some practice with our little application over here. So we've added one. Let's add LVS, ERQ, NTI, and a few others, YZZ, ZVQ. Thinking of these off the top of my head as I go. And let's add a few indicators onto these. So let's add the Chand Momentum Oscillator. I've never used that one. It's in the TLib list, so it's come up. And Bollinger Bands, everybody uses that at some point in their existence. We have RSI, and let's add a stochastic RSI over that as well. So there are two types of indicators that will go onto your chart. QuantMod would automatically identify what type. The two types are either on the figure itself or as an indicator screen at the bottom. And this sort of layout is something you're probably familiar with, having used different trading platforms in your time. So usually an indicator such as, for instance, a moving average. Let's add that over here too. Moving average, basic moving average with default parameters will likely go on the chart. Let's zoom in to get a better look at that. Zoom in even more to get a better look at that. So there it is. You've got your Bollinger Bands, you've got your moving average and your quote series. So things like this can be implemented easily. And the moving average being an example of an indicator that would get plotted on the series itself, and other indicators such as the CMO, the MOM, the RSI, the stochastic RSI, etc., being plotted as separate indicator windows below the main chart window. So very much like a regular trading platform. And this is all accessible via Dash and via QuantMod. Thanks to QuantMod's features and the ability to make the financial calculations and rendering of the same very simple to do via Plotly Dash and QuantMart combined in Python, we're able to generate solutions like this very, very fast. And big hats off to the developers behind these amazing libraries. And that's pretty much it for today's tutorial. We've built our very first building block, which is the chart itself. In future tutorials, this script will be changed in the sense that this isn't really the main terminal script. So for today's tutorial, we just called it DWX Trading Terminal, but we will refine our code, structure it better as we have with previous tutorials, using whilst developing functionality via the REST API and segregating things into their own scripts, having proper inheritance to make our code more organized and reusable as we build out the solution. So this particular tutorial's code base will obviously go in a chart specific piece of code somewhere. So we'll be changing this up as we go along in future tutorials. Hopefully you enjoyed it. See you in the next tutorial. As always, if you enjoyed this presentation, please do consider sharing it with your social networks, colleagues, co-workers, and friends. And do subscribe to the Darwinex YouTube channel so you remain up to date with all future videos that will be released in this series and other topics discussed on Darwinex. Thank you very much for your attention. See you next time.